Okay, don't worry, it will not take too much time. And actually, more than a presentation of the book, it's as it might be also the occasion to discuss a bit together about the academic market of books in physics. There is also, as some of, perhaps most of you know, we have organized a survey on teaching and learning statistical physics, and we will be one of the topics of the final discussion on Friday afternoon. Anyway, for the moment, we discuss about the book. So, why we have decided to write the book? I mean, it's just a very rough statistical data, both in online bookshop and in online libraries. The books with the string Nonequilibrium in Nonequilibrium Statistical Physics or Nonequilibrium Statistical Mechanics is around 10%. Or even less. If we look for books on non-equilibrium statistical physics for students, as you know, not as you can imagine, as you know, is even less, and the fraction of modern books for students is even less. So perhaps the percentage dropped to 1%. So the content of the book is mainly divided in two parts. Perhaps, Roberto, if you want to say something about this part. I mean, a more traditional and a more modern part.
Yes, for what concerns the first part, essentially we discussed together for a long time how to organize these topics. And essentially we try to follow a not completely traditional or conventional way of presenting these topics. And the first part is really something that is the basis of everything. And we are actually discussing for a long time one of the items that were raised during our last discussion about this problem of the interstatistical representation when you have to derive stochastic differential equations from the inspiration of Brownian motion. Essentially, starting from a physical problem appeared to us the best approach. So you have the Brownian problem, so you have to deal with that. And this is, in general, the way this problem is approached. And but we tried to make our best to provide a presentation which could be at least consistent. I must confess that every time now I'm going through again these topics after 4 years of work. As I told to many of you, I had the feeling that I couldn't really understand if I had got the goal or missed completely the goal. At some moment, at least to me, all the framework blew up in my mind and I didn't realize what we had obtained. Then it's clearly just a phenomenological fact that we will understand later if this worked or not. I mean, I must say. But on the other hand, at the very beginning, the very inspiration was this one. So start from a physical problem, try to explain things, generalize them, as Emil was mentioning in his talk. Essentially, we try to give the standard presentation, but then go back to a sort of more mathematical formulation. But we want really to be rigorous in the real mathematical sense. We want just really to be logically consistent in some sense. And probably the idea of introducing certain concepts was quite important. As you have seen, many things are collected in a lot of, also for this part, in a lot of appendices. Where in these appendices we just try to make self-contained topics, but just to give tools to the student that can read and understand about things. So I remember that we spent quite a lot of time about Kramer's Moyal just to explain his technique of how it works. and why it is important. Because otherwise, I mean, it's a projection technique that others don't understand, just leave it that way and so on. Then the point that we tried to introduce is the generalized random walk theory. There are many books which are devoted, in my opinion, essentially to specialists that are different from that, very good ones. But on the other hand, I don't think that this is explained carefully in the textbook for students. And this generalized random walk problem is very important for a lot of applications. And okay, we decided at the end to include it, and we realized, unfortunately, that our book has probably some, I don't know how many, but some mistakes. But many of the books that we went through just reading these topics are full of mistakes. Just misprints or things that it was a bit an amazing discovery. I didn't believe that at the beginning. Then I was saying to Paolo, maybe when we discover how many mistakes we did, it's shame on us. For the moment, nothing.
Misprint, but not mistake.
Yes, and the other topic that we found very difficult to introduce, and we discussed a lot about that, is the second part that concerns linear response theory, which is treated in a very different ways and sometimes, in my opinion, not very clear to understand, at least from the point of view of the student. And our choice at the end was to say, let's start from the very beginning to stress the importance of measuring correlation functions. This is a very basic tool. I mean, physics is really something that you have to deal with every day in your life. So, I mean, this is the basic thing. And how can you estimate, how can you understand how these things can be related to linear response? So, these things are very important to be explained. And I think that in some sense we really try to explain these problems, devoting also some quite lengthy introduction to these chapters in order to make the reader acquainted to the idea that the basic things have been organized according to its basic facts. So the importance, in this case, of measuring equilibrium correlation functions, and then from that you can, in some sense, derive a lot of very interesting things. Another effort that we did, which is make the new book at least a bit unconventional with the other kind of books in this field, is to treat in a reasonable span of time and space the problem of Zaga relations. This has been confined for a long time to a sort of chemical problems. They are not at all chemical problems, as all of us know, and the presentation is usually quite unsatisfactory, at least to me, I must say. I don't know if our presentation is satisfactory, but we try really to make our best to explain why it is important. And also the topic concerning coupled transport, despite our attitude or really personal interest in this kind of research problems, but it's very basic. It's a very important fact, which is concerned symmetries and many things that borrow very basic concepts. It's not just a phenomenology. You have, I don't know, the Seebeck effect or something. Yes, okay, these are the physical effects, but then you can trace back all that to symmetries and very important things. So we try to make our best, still in a presentation that was not too formal, because clearly you can provide a presentation which is very formal. You can start from group theory, algebraic approach, and many things. But I mean, this is not the, how to say, the attractive point of view for a book which is called Nonequilibrium Statistical Physics. And this is not by chance that we decided to put there physics rather than, mechanics or mathematics. It's physics, so we try to go in this direction. And that's why we spent quite a lot of time in order to explain this fact concerning the Zaga relation, the kind of problems, and so on. So in some sense, also this part of the book can be organized at different levels. It's clear that the basic things can be part, at least in our tradition, at least in Italy, to organize a very basic course at third year or maybe first year of a master's degree at thesis level, but then the other parts can be easily borrowed to organize some more specialized courses for PhD students or, I mean, fifth year students of the master thesis. So, in some sense, also the book was taught in this modular structure in such a way that one could arrange these topics according to the goal that one wants to achieve, to teach these things to the students. What is essentially missing in the book, in my opinion, but then Paolo will more or less comment on that the same, are exercises, and there was really no space to introduce them, no more time, because this book would have been ended 2 years after, and this was not possible.
In fact, Angelo has 42 exercises already prepared.
Yes.
You are exaggerating, I'm not a real exercise.
42.
Yeah, 42 is 42, but so it's not, many are not real exercises, are just a recapitulation of some theoretical aspects, some are...
We knew before.
You can, it's free, it's on my page, you can take it.
And the other missing thing essentially is a real rigorous approach in the sense of mathematics. Personally, this is my personal feeling. I think that a truly rigorous approach would make us gain a lot of things, but I would say more as researchers than students, at least in the realm of physics. So I'm not saying this is not important, but you cannot put everything in a book, otherwise write an encyclopedia. But that would be really very important. And developing some specialized courses in order to introduce people to the basic, fundamental, and rigorous aspects of this kind of physics would be, in some sense, useful for some of them. Not for all of them, but for some of them. And okay, then we entered this part of the non-equilibrium phase transitions, which is still a bit, I would say, not completely, how to say, standard. Because, but then also in this case, the very important point was to provide a presentation that contained all the basic things coming from equilibrium that may be useful for non-equilibrium. In order to find in the same book these topics together, because for instance all the ideas about scaling and so on are very common to both of them. Both of the approaches. And this is important to make people understand that even if you introduce a sort of extra dimension, which is time, that you have to deal with non-equilibrium, but nonetheless, you can still exploit the same kind of language, which is extremely effective to describe critical properties or other scaling properties. And that's why, at the end, we decided to introduce this part, which is a bit conventional. You want to comment on that?
As you know, just this part covers the entire content of many books. There are a few books on non-equilibrium phase transition, surely not directed to students. And as for the new part of non-equilibrium statistical physics, it was just a question of taste and personal interest. And so, I mean, we have decided to do one chapter on kinetic roughening, because especially in the last few years there has been a renewed interest in KPZ, the problem of phase ordering kinetics, let's say when you have relaxation to equilibrium of a system after a quench through a critical point, and finally some highlights on pattern formation. In some sense, this structure also allows to use the book in a sort of modular form. So I mean, you can take, it is not really necessary to go through the beginning to the end of the book. I mean, you can read one chapter and give a series of lectures just on that. After a personal choice, of course, there is that each one of you will have his or her favorite missing topic, of course. Okay, the Boltzmann equation for Angelo, because the Boltzmann equation is not there.
This is actually my student.
Yeah.
I strongly suggest your book the day after.
They complain.
There is no Boltzmann equation. And you say that Boltzmann equation is very important, but it's not. In the book, you suggest that.
Okay, so this is the real reason why you complain, because now the students have the feeling that it's not so important, the Boltzmann equation. No, of course, fluctuation theories are completely absent. Well, granular materials, disordered system. I mean, this list is just to say you...
Large deviation.
Large deviation. To say you, not in a formal way, that since for the reason that you will see later, a second edition is very unlikely, if you have your own notes, or you know notes which you think that they are really pedagogical, especially on topics that are not covered by the book, but even if they are covered, we ask you to let us know, because in a section of the website we are starting to collecting materials, for example, on granular materials, disordered system, and so on.
Also something that we wrote that we didn't publish, because we had some parts already written on these topics and
these are some preliminary results from the survey, just to frame, a type of book like this one in existing bibliography. These are, okay, so we have received the answer for 450 teachers and almost 200 students, and each person was asked to indicate the books useful for the course. It is a multiple answer, so the sum is not 100, and for each book you find two data. The first one refers to teachers, and the second one to students, and also the date when the book appeared for the first time, or for the most recent edition. And this for any topic in statistical physics. And the first one is Wang. I don't mention you. Just you can check the list. On the one hand, it is very natural that the answer of student is not so much different than the answer of teachers, of course. While the data for teachers, I think that they are reliable, because there are a lot of answers, and I don't think that there are meaningful correlation between the answers. Instead, it is possible that there are correlation in the answers of students, because it is possible that that students attending the same course have decided to answer together. So instead, this is not the case.
Can you remind us or tell us how the survey would? How did you choose the 450 teachers? Out of which sample?
No, we at the École Normale in Lyon, they had a very large mailing list, which is used to inform all the community throughout the world. And so we have used that one. So in this sense, we have not...
No, I was in the list, but I don't remember.
No, but in fact, a few people which I expected they should have received, they didn't. So I don't know, because it was strange. Perhaps there is also some mechanism of spam. Actually, I don't know.
Maybe you have to explain what these figures do not sum up to 100.
Yeah, because there is multiple answers. There are multiple answers. Instead, if you focus on non-equilibrium statistical physics, you find here to Gardner and Van Kampen. But if you just focus to the list of non-equilibrium statistical physics, you find Gardner, Van Kampen, Riske, Kubo, Toda Hashitsune, and finally a comment on the date. I mean, this is perhaps I think the most recent one of all the list. Yeah. I mean, if you don't know this book, the title is Statistical Physics: A Kinetic Approach. I suggest you to browse this book.
Yeah.
And then just we conclude this part on a question that I think that should be important for all of us. I mean, I have recently had an exchange of mail with Simon Kapelin, who is the editorial director for physics at Cambridge University Press. And I mean, at a certain point, he made this statement. Says of any given kind of academic physics books have halved in the past 10 years. And I mean, I have found this statement very strong because, I mean, we are speaking short period, 10 years, not 50 years. I mean, in 10 years they have halved. This statement was to justify the fact that we should not expect to have a large amount of books, of course.
It refers to the whole market or the experience of Cambridge?
No.
Okay, I think that, let's say now if you say here why, you can see that for other publisher things may be slightly different. But at least if you refer to not to e-book, but or to the book that is accessible from the library in electronic form. But if you think to the paper copies, I think that this statement is fairly general.
Yeah.
So we have asked him why. He's in the editorial bureau, not in the sales bureau. So and he has not really, quantitative data to support this hypothesis. But we should take them as a strong indication because he's the editorial director. Okay, institutional e-book sales means that, for example, you can go to the website of your library, and you and your colleagues all have access to the e-book. And this means that in the same physics department where 10 years ago perhaps the book was sold in 2, 3, 4 copies, paper copies, now they perhaps buy just 1 copy because the other have access to the book. And that counts as 1. It does not count as 5 or 10. It counts as 1. Okay, piracy. Something which is connected to the first one. Reading habits have changed. So not only the book is now available in electronic form, but it is available in different files. Each chapter is available as a different file. So now, in some sense, people approach books with an attitude which is more similar to journals. You are looking for information for when a given topic is treated, and perhaps you go to Google Scholar, and you find not only the journal, the articles, you also find the book. And with, for example, the Springer Link program, you have access to the different chapters. And this means when he says reading habits have changed, in the sense that now you simply go there and browse the chapter where you are looking for your information. It is more rare that people buy and read more or less an entire book. And finally, of course, economical reason, in the sense that the number of science books has increased in 10 years, but the budget for books of library has decreased. That's all.
I want to make a comment, because that would be nice to think about the possible correlation that appears from these 5 considerations with the list that we have shown before about the most used book in statistical physics. And these data are a bit concerning me, because I must say, I don't have no problem to say that the first 2 books I don't like at all. I studied on these books, and I find that they are quite misleading in many aspects. The approach of Landau was clearly biased by his own ideas about the low large numbers, and I mean, this is, in my opinion, not really acceptable in modern times. And the Wine book is really unsatisfactory from many respects, mainly when he discusses Boltzmann equation. And this is the don't like.
Landau is clear, of course. It's very synthetic, but it's clear.
One he speaks about fluctuation is really messy.
No, you don't.
I remember when I was a student, I say, what are you speaking about? So, but this, in my opinion, could be in some sense correlated to this fact, because apparently, if you realize that still today, these books are the most used. Which means there is sort of inertia in cultural statistical physics related to books which are really traditional, but in my opinion, they're not really up to date. At least this is my opinion. Maybe you disagree with me, but this is my personal experience.
I think that they are the most used because of tradition. In fact, if you find the 2 books which are not a traditional book, they are just 10 years old. I mean, the book of Carter particles, the book of Carter fields. Perhaps in 5 and 10 years, the same survey you might see Carter here. I don't know.
Maybe, but for the moment, these 2 books are the most used.
Yeah.
And okay, I mean, in my opinion, I remember when I was a student, I studied, I was saying before, on these books. Well, why they were really useful? I want to say that they are something that you put together. They were useful because essentially the idea was this one: you teach these things by considering different examples. You did that and that and that, and then you're able to understand how to make calculations. That was the main point. But you have any attempt to grasp some foundational problem or make links between different things, you were lost. That came later, after you were upon your experience, you were trying to make calculation by yourself, and work out models and work out calculations, then you start to realize that some relations that appeared there, they appear on the other side. For instance, when we wrote the book, we realized that many things that you can deal with about personal transitions and concerns, closening and so on, so you can rephrase many things in this way. But at that time, at least to my experience and to my goal, that was very hard to me. I had the feeling that everything was just a collection of calculations. You took easy model, you took that other thing, and then there was some. I remember the discussion which is on the one about normalization group is another thing that made me mad for a long time. So, nonetheless, they are still on the market. Essentially, they're still on the cultural market. I'm not saying that they sell the book, but essentially people are trading in these books. Now, this is a fact. I'm not saying that one has to give up books, but in some sense, if you want to go toward, certainly these books are already hard in general, standard difficulty for physics students. This is my also experience, not only as a student, but as a teacher. can imagine if one should learn statistical physics coming from another discipline through these books. No way. So going back to my initial comment, there is also the problem to transmit this kind of tools to people that are not essentially physicists or mathematicians, but which may make a proper use of these things. What is on the market to cope with this aim, provided that we are interested in this aim? I personally believe that there is nothing. Even our book is not.
I don't agree.
You don't agree, okay.
No, for instance, take Ken Dill's book about physical chemistry. It's a wonderful book, and it's for that market.
Okay.
Or there's a nice book by Zuckerman on statistical physics of biomolecules. So I think from the physical chemistry side, there's a handful of decent books. And of course, they are more accessible for chemists than biologists because the mathematical level is not too high.
I mean, if you know books which are not listed here, they
Yeah, and we are not able to with Antonio, the book of Sekna starts.
Certainly was not.
Yeah, I mean, it was listed,
Okay.
but somewhere here.
It's a very nice book. It's not the standard text.
Certainly.
Oh, Sekna, yes.
Sekna.
It was 1%.
No, okay, it's below on the.
Yeah, no, it is under.
On the queue of the distribution.
Yeah, but I have a question about the market. I mean, you said that it halves in 10 years, something like that, but one should compare that to other general books, I mean, not only physics books. This is a common trend, or it's just for physics?
For academic books in science. Academic books in science. He's speaking in physics, but he also commented that he is fairly sure that also in other disciplines, but academic books. Here we are speaking about academic books.
Okay. Novels and so it's different. For novels and other things.
No. I don't think that.
Maybe it is worse. Maybe it is worse.
No, I don't think so.
But on the other hand, for instance, this kind of book, if you sell in 1 year 500 copies, partly according to their own valuation, that is a bestseller.
Yeah.
1,000 is considered a good success.
Yes.
Sorry, are there data of how many books were sold 10 years ago to libraries and to private people, to students directly? Since I was wondering if it's true that these books are
10 years ago there was no ebook from
and
there was no Springer League.
Yeah, no, but the physical books were bought by individual people or by libraries. To which kind
the digits refer to individual copies of the book. I mean, the copy of the book sold to a library has the same weight as a copy sold to
I understand.
I think that this is interesting, and this is interesting data. I mean, because I think it's more a matter of use and attitude. No, okay. Because after all, electronic books, I mean, they have a key. I mean, they usually are protected. So at the end of the story, it doesn't make any difference with respect to before that you buy a book and then you give, I mean, for reading to your friends or to your colleagues. My feeling is that this should be really analyzed because probably is the way in which we use the information and culture that is evolved, in the sense that it's more when your analysis, I agree more with the analysis that you did, the fact that we use in books more as articles than as we used before. But you have to think about it, it's interesting.
One thing to mention is that there are a lot of lecture notes on the web. And people do use lecture notes which are available from all kinds of places as teaching material, which were not available 10 years ago. So that could be another reason. Yes. Agree.
I mean, I think the main reason really is number 3. In the internet, there's so much information available to students. I ask my students, you know, which kind of book have you read? For instance, Christmas time, when we start in October.
Google, they said Google.
There are many students in my course who do not read a single book on quantum mechanics. You know, they take what I put on the blackboard, they copy, they have scripts from the internet. You know, many colleagues have their stuff on it, and then they just collect like this. Or go to the office of your PhD students and look how many privately bought books they have on the shelves. I mean, none of the PhD students buy books anymore.
Absolutely.
Yes.
And compared to what you have bought when you were a PhD student yourself, it's completely changed.
Yeah, but it's also
Surely the second item there plays a role. I mean, as a student nowadays, I mean, any of those books that are on the list, in 5 minutes you get it on the internet from some website. I mean, so as a student you don't have much money.
And then, this is part of the illegal market, okay? But it plays a role. But it plays a role. I mean, I think I agree a lot with what Udo was saying. That even you see that you discuss with students, and our first reaction is to go to the bookshelf and then to look for the book. The first reaction is to go to the computer and look in the internet. Probably they are faster in finding the data that you need. I mean, and okay, so this is a matter of changing.
Many theoretical courses in the internet from different university professors that put the material chapter 1, chapter 2, and so you can find in different disciplines.
Yes, you know, this is a quite widespread attitude. Students are always asking for notes. They want notes for any course.
Yes.
Because in principle, notes are in some sense a guarantee of what they're being asked about. But this is something that personally I don't like. I don't really have people to go in this direction. Despite we wrote notes, and that's the basis of this book, I always push the students to present other topics, and the examination I ask these topics. So if they don't go on the book and read them, they don't go to the examination. And I think it's important, in my opinion, that the student has the habit to compare. I don't care if it's good in e-book, anywhere else. You have to compare them.
Yes.
Otherwise,
Comparing is one thing, but the other thing, which is also missing, I think, these days with the student, is that they read. I tell them, it doesn't matter which book you read, but read one book coherently. You know, you should not take this from this book, this from this book, this from this book. A good book will have an internal consistency and will show links between the subfields. And I think that's what's most lost these days, are the connections, the structure. You take it from Wikipedia here, from one script there, from here, and at the end you have seen, 10 notions of entropy, but you don't see how they fit together.
Absolutely, yeah.
And that's, I think that, it's one of our tasks as teachers to tell them the unique value books have in that regard.
Right.
Because this is some cultural thing which gets lost with these bits and pieces from here and there. Everything is available.
I mean, there is a hierarchy in some sense.
There is.
There is sort of a hierarchy of importance of topics, and you cannot read anything. I mean, you can read in some logical order or in some logical relation.
I think that's for theoretical physics.
That's the point.
Yes.
That is the point.
Especially because understanding a topic is something more than giving answers to specific questions. Instead, when you browse, journal articles, chapter of a book, chapter of another book, it is useful if you are looking for a specific response to a specific answer.
Yeah.
Yes.
Absolutely.
But not to understand the basis. There's any comment from the student component of this meeting? Are we saying stupid things? We are guessing what the
I totally agree with what you said about reading a whole textbook to get a coherent picture. I think that's very important. And there's some courses you have lecture notes, and then they'll say, okay, here are these 8 textbooks that you can read and choose and do whatever you want. And then it's kind of difficult because you have to start reading all these textbooks and decide okay, which one is the best, where do I like the notation and so on. So there's the risk of ending up just picking pieces from different books and you don't get like one coherent presentation. And then some other courses are more tied directly to a textbooks, and I've found that for me more valuable when you have like from the start. We're going to use these textbooks. If you want to explore some other things, then you have these where tying this course to a specific presentation. But then of course there needs to be actually a textbook that covers what the lecturer wants to convey in the course, and that's not always the case, especially in non-equilibrium courses. Does that make sense?
This is your experience.
Now we know which book to recommend in the future, right? To all the students.
Okay, so I think we can stop here. At 6 we are supposed to have this wine class.
No, we have to